So we are talking about the petroleum system processes, and we said that there are three stages of petroleum system. It generates in source rock, it migrates, and then it accumulates. As the drilling engineer, production engineer, or reservoir engineer, we manage actually the accumulations or the reservoir pools here. This picture is actually very nice, and here we talk about mainly the generation. Here you see that the generation. Then if it finds any fracture, any space, any movement from where it can come out, it moves until it attaches to any seal rock here. So here is the seal rock. And as we said that oil, gas, and water are in three different layers they are forming in the reservoir. This picture usually represents the most reservoirs of the world, where gas is at the top as a gas cap. Then we have the oil, and then we have the water. But sometimes this oil also has some gas here also. So in the last lecture, we talked about the two theories. We said that there are abiogenic and biogenic theory. Then we say there is a source rock that is capable to generate. We talked about the kerogen, which is the material responsible to manufacture oil and gas over a long period of time. Then we talk about the diagenesis, catagenesis, and metagenesis. We said that the diagenesis is the process where the dinosaurs and O's are converted into the kerogen. And catagenesis, it composed from kerogen, it becomes bitumen to the oil. Then metagenesis, it becomes oil, gas, and further. So then we said that further, when this oil is generated or gas is generated in the source rock, then it is migrated through using the migration. So it could be because of the oil and gas seepage, it could be because of the fracture, or it could be because of any way that it can go out of it. We talked about the reservoir. Reservoir actually is the rock where it is the oil and gas accumulation. Uh, Actually, reservoir rock is the one which we drill. We try to reach there. We call it a formation also. We also call it a pay zone at the same time. And the two parameters are important for reservoir rock. One of them is the porosity. Another one is the permeability. We talked about both of them also in the last lecture. We said porosity is a small space available inside the rocks, and permeability is the connectivity of them, and connectivity and how easy the fluid can move from one point, starting point, to the end point. This is we talk about the permeability. And porosity usually we can find using the logs. We have the geologists, they have the logging tools, they find out the porosity using that. The other way to get the porosity is to take the rock sample during the drilling process. Sometimes they do the coring job during the drilling process, through which they take the sample of the rock, and then they analyze in the laboratory and find out the porosity of that rock. And permeability, there are a few ways to find the permeability. Actually, there's first way is to find permeability through the well test analysis. Well test analysis actually is a method they use pressure versus time and some calculations to find the permeability of the reservoir. The second way to find this permeability is actually the laboratory. In laboratory, they take the rock samples from during the drilling process, they take it to the lab and they analyze that how much permeability it has. These things you will study, we will study in the next lecture, porosity, permeability, and their laboratory experiments and ways to find them, and so on. Because next lecture is about the reservoir rock and fluid properties. Then we say that there is a seal rock which is existing and which actually inhibits the oil to flow further. If you look at here, this is the seal rock we're talking about. This is the seal rock we are talking about. Okay. Then we are here. We stopped at this point in the last lecture, and now we are talking about the traps. What are the traps? First of all, they are the seals. Seals which don't let oil to go out of it, so they trap it. Okay, in real life also trapping word is used quite extensively. For example, the trapping of the rat. Sometimes you put something in the home just to trap the rat. Sometimes there are many other things that happening. So we use the trapping word a lot. So here trapping means actually also the same. It has the same sense. What does it mean that we are just trapping the oil? Not we are doing it, actually nature is doing it, and it is giving it a seal so that the oil do not go here and there. It should stay trapped there. Okay. For example, now we have two different kind of traps available. One of them is structural trap. Second one is stratigraphic one, and third one is the combination. First one is based on the structures. You know, it should be based on the structural style. And other one is should be based on the properties, based on the properties of the rock and so on, or disposition and style and so on. So this first one is because of the structure. Second one maybe because of the properties of the rock. Maybe there's no porosity or so on. Third one could be both structural and stratigraphic. So we will show you some pictures about them, and we'll talk about it. Let's look at the first of structural trap. Okay, it is done lots of years ago because of the earthquakes, or because of the movements of rocks and plates. So structural traps are formed. The most famous of the structure is the anticlinal. So this structure actually we call it anticline structure. So now you see it has this is the reservoir we are talking about. The above one is a cap rock. This is the trap we talk about. It is also called the trap rock. You can call it seal and so on. So you can see it. Okay. Now this fault trap, or this one, is because of the earthquake. Sometimes the rocks breaks. So what is happening? Let me make a picture for it on the whiteboard. For example, I will share two scenarios. Here, for example, we have the rock something like this one. Then we have actually let me make another rock. Okay. Now, what is happening? Let's say earthquake happened, and because of the earthquake, what happens? This part of the rock, this part may move up. Okay. Now I can. This part can move up to the here. So the real picture after this, the earthquake made something look like this. Now, previous situation, this is the, you can say, situation one before earthquake. This is situation two here. After earthquake. Okay. After earthquake, what happened? The rock, which was straight, it break into two parts. One part goes above, the other part goes down. Okay. Now, and you can see now this part here they're blocked. This part is blocked. So, for example, if there's oil, will be because of this breaking of formation, there will be no way for this oil to go to this direction. No, it cannot go. So actually, there's no chance that this oil can go from here to there. It's stuck. And the oil is there in the upper zone, and oil is there in here in the other zone. And because of the earthquake, the rock becomes into two different sections. One section goes above, the other section goes down, and they break it down. Now, my question here comes, a very important question here needs to ask. For example, pressure here is 2000. Our pressure here is 2100 psi. We talked about it before that as we go down, the pressure is increasing. So this is above and this is below. So it has to be 2000 and this has to be 2100 also. Okay. But here, what kind of pressure you are going to expect? This is the question to the student. What kind of pressure you are expecting here? Anyone can hear me?
Lower than 2000?
Anyone else? This is the same on this rock actually. I'm talking about. This one represents this one. It's the same one, but because of the earthquake, it divided into two parts and made a fault or fold, whatever you call it. Okay, now my question is, what will be the pressure here?
So, sir, it should be higher, right? Because the oil comes out from the reservoir much easier.
Number. I'm talking about the number. I want the number. Okay, I can tell you that pressure here is 2000 because this represents the same as this represents the above one. This is 1, this is 2. So this is 1 and this is 2. Here this is 1 and 2. This is 2. Yes. But here is before the earthquake, but after earthquake, this below one goes above. And as I told you before, the pressure here is 2100. So what will be the pressure here? Well, the pressure here will be 2100 because it's the same rock. Okay, so oil is still the same, but because of the earthquake, it just changes place. So pressure inside remains the same, 2100. But on the other side, here pressure is 2000. So here comes the problem of blowout and high pressure abnormal formations. As a normal, as I said, there's a pressure gradient per feet. That's 0.4333. The pressure gradient is 0.433 psi per feet. Psi per feet. So now, for example, you are drilling 3000 feet. Drilling 3000 feet. 3000 multiplied by 0. Anyone can tell me how much it is? Can multiply for me? Anyone can please?
1299.
1299. So psi here, 1299 psi. So as a normal, we said that per feet pressure is 0.433 psi. We drilled 3000. We should get this pressure, 1299 psi. But what is happening? There's more. This is not the real value. In reality, pressure was 1500 psi. We estimated based on the gradient, the pressure is 12,900, but in reality, the pressure was 1500. What is the reason? The reason is that because of this fault, because of the earthquake, the formation, which was supposed to be below, has gone up. Okay, and because of that, the pressure which is raised, and it means that there is a fault, and because of the earthquake, the formation has moved up. That's the reason. Also here, all is not 2000. Here is all not 2100 like this one before the earthquake. But after earthquake, what happens? This rock breaks down. Some of the part moved up because of the high movement because of the earthquakes. So that's why. But the pressure still is intact, which is 2100. Got the idea? Anyone?
Yes. Yes.
So in simple, you can define that earthquake creates faults. I can write it here for you. Earthquake create faults. faults moves up the reservoir rock. Sometimes we get erroneous spelling, I don't remember, but something like this, erroneous pressure due to faults and the upward movement of rock, earthquakes. So because of the earthquake, structural trap is formed because of the earthquake breaks down and makes the structural trap here. So that's the idea behind it. The same thing you see here, the fault traps. We call the fault here, this one. So these are the structural traps, we call them. Then we have, look at this one. It's a very beautiful picture. You will see this picture in all oil industry, all petroleum engineering courses, similar kind of picture. So there are two terms here, GOC and OWC. Can anyone tell me what are those? Anyone can give me an idea? There are 17 participants and I hope that all of them are on board with me and not doing the other jobs. Anyone please? Okay, this gas oil contact here is actually, GOC is actually gas oil contact. It's a transition from gas to oil and that's why we call it GOC. So oil and gas meet at this point. And the other one is the oil water contact. It means that the oil and water contact at this point. Okay. So we discussed that gas is at the top, oil is in the middle, and water is below. So it's a very nice and above one crest of it makes an anticlinal structure, and we call it a cap rock above them. That's a very beautiful picture of this one. Then look at this one. Okay, there's an oil here. It didn't move here, but fault has created here. Okay, so now it is trapped there. And in this one, not completely closed. There's no complete closure, but there is some movement here. And here is totally earthquake has moved both of them. Now here should be higher pressure than expected because it was made below, but because of earthquake the rock moved up. So that's why. And of course there's some leakage, seepages here, so there is spill here. And of course the same thing but opposite direction. There's above, but it goes below. It goes above, the other part goes down. So this is the assumption. So there are 6 trapping. These are called the structural traps overall in this case. So the anticlinal structures and the faults. Then the other one is the stratigraphic one. These stratigraphic traps, pinch out or unconformity or reef, they are actually not because of the structural or it has a seal above it or what. No, it is because of the porosity, or maybe there is no porosity or there is no permeability. Rock is the same, but maybe it has no porosity and permeability, so it is because of the properties of them. That's why they are happening. Okay. So sometime you have to look at it. Whenever we drill before the zone, there is a chance there should be an overpressure shell. The pressure will be a bit higher than the reservoir pressure. Okay, it is a sign that there is a chance that below is the reservoir. Okay, whenever we drill, we especially take care of the shales because shales tell us that if a high pressure zone or over pressure zone is coming below it, above it should be the shale. This is the conventional thumb rule that we talk in oil and gas. So overpressure shales are a very good indication that below is a very high pressure reservoir. Shale is a kind of a seal rock or trap or cap rock you can call it, and so on. Sealing mechanism. Here is the sealing which is happening. So for example, if you think that here is the oil, this white part, let's say, talks about the shale. So pressure in this shale will be higher than this one. And if you look at surface during the drilling process, we are definitely monitoring all the shales, all the pressures also. So if the pressure here is higher, okay, it tells us that below this there could be a chance of high pressure reservoir. We have to be very careful for the shale drilling. Whenever we drill the shale area during the drilling, and we keep monitoring its pressure, and that's how we identify. So basically, always take care of the overpressured shales during the drilling process. That's one of the jobs.
Sir, I had a question.
Yes.
What if the shells has the lower pressure?
Uh,
What will happen in that case?
in that case, there is a chance that the rock is very well compacted. It has no porosity, and we can proceed with normal drilling.
Yeah.
Okay, in that case. And for the structural traps, mostly the big giant oil fields, they have this kind of structural trap as we always make the picture. Okay. And they containing more than 500 million barrels of oil in this one, especially in Middle East. This structure is quite common and is happening here. Okay. So most of the world's largest anticline and have been drilled. Okay. So now what we are looking for is the smaller prospects in other regions. Plus, the structural trap is one of the main reasons to find the reservoirs. When the geologists and geophysics, they do the seismic survey, they basically look for the structural traps and so on. They find out the location of the structural trap in the pictures based on those SN periods. Then for the stratigraphic traps, they are not because of the structure, but it could be because of the property of the rock. Could be impermeable rock, could be two different kind of pinch out type and truncated type. These are the reasons and properties of the rock that they are talking about. Simply, you can say the rock has no permeability. These are the stratigraphic traps, and here are some pictures I will show you here. Truncation. So we have oil and gas. It has no sealed rock above it. Same reservoir, but it has no permeability. That's why it is stopped here. So you can say that. And unconformity means there's a gap in geological record, periods of erosion not discovered. So again, it's a property kind of a thing. It has no different seal rock or so on, but because of the erosion didn't happen well, so porosity permeability is not good enough. Otherwise, rock is the same, but it doesn't have the porosity. So this is also quite common. But the structural one is the more common and easier way to find out and drill the reservoirs. In this one, here is it. Water and oil flow. Sometimes what is happening, the reservoirs are connected by the nearby lakes. Nearby, for example, Dukan Lake. So there's always water at Dukan Lake. So maybe there's a channel from Dukan Lake to the below of the reservoir. So water from Dukan Lake is going down and supporting the reservoir. And there are many, many cases around the world, especially in Middle East, where water from the surface or from any lake or sea or pond, it is directly connected with the reservoir through the channels or fractures or fracks. So that always sometime happening, and this is called the hydrodynamic depth. So basically, it's not in structural or stratigraphic flow. That's because the water is just stopping it and keeping this well, what oil and gas there. Then there's because of the sediments less than the above, salt and clay, different size of the particle size. Sometimes the traps are happening. Okay. In this one, there is salt and tapping the cap rock. And basically, for example, now if I show you, okay. Now, for example, we have a rock here, and we have the bigger size of particles. So here porosity permeability is very good because the particle size is big, easy. But in the smaller one, it is then because of the erosion or bad one is happening something like this. It's the same rock, but now the particle size is lower. Now my question is, which part has the high white area and which part has a low white area? For example, I divide into the two parts from there till there. This is one rock. Now the other one. Which has more white area? or porosity. This white represents the porosity or space where oil can be held. So which one has more, first or second?
The bottom one?
Yes, bottom one definitely has more. Why it has more? Because the rock size, the particle size here is bigger. So even if they get closer, there is a lot of space between them. Here the particle size is smaller. When I talk about this area, this is bigger particle size. Okay, and smaller particle size. Smaller particle size and bigger particle size. And because of that, it has this one has lower permeability, lower porosity, lower permeability. This one has high porosity, high permeability. It's because it has, because the grain size is bigger. Any question from it? Okay, I will go back to the lecture now. Okay, so the same thing is happening here, change in the particle size in this one. So a seal is a fine grained, means the particles are fine, means smaller. That prevents the oil from migrating from upward movement. So there are so many seals available: salt, muddy, and siltstone. Very fine particle like a flour, wheat flour or rice flour you use at your home for cooking. That kind of small. So the smaller the size of the grain, less is the porosity or permeability, and that's how we avoid. We seal sometimes the reservoirs are sealed with it. Well, basically the geologists, they identify, they call it. This is not, as an engineer, this is not our job to look into the geology and so on. The geologists do that. What we do is actually just, we know that this is the reservoir, it has a seal, and we need to drill it, we need to produce it, and we have to manage it. We don't care for the geology, rocks, minerals. This is not our job. But at least we should know that which kind of rock we are dealing, how much is its porosity and how much is its permeability. So that's it about the one. Okay, do you have any questions from it? Any question? No question. Okay, so we will end it here. In the next lecture, we will talk about the reservoir rock and reservoir fluid property. What are the reservoir rock and fluid property? I will just introduce the basic concepts. It's a complete course in other universities, but in this case, we will just talk about the basic definitions and so on. For more information, I will give you some books also and materials you can refer on them personally. Okay, so see you guys in the next lecture, and thank you very much.
Thank you so much, sir.
Thank you.
Thank you, sir. Have a good day, sir.
Have a good day. Thank you.